Hello friends, we will be covering the following in this video. Constructive superposition of two waves, wave cycle terms, destructive superposition of two waves, mathematical analysis of superposition, methods to create coherent sources, interference, Young's double slit experiment, dark point, width of the dark fringe and bright fringe, width when slit changed from the source. Superposition of waves. The principle of superposition may be applied to waves whenever two or more waves are traveling through the same medium at the same time. The wave pass through each other without being disturbed. The net displacement of the medium at any point in space or time is simply the sum of individual wave displacement. When two waves having the same frequency travel with the same speed along the same direction, then here please note in the picture these two waves are starting and ending at the same time. This is wave 1, this is wave 2. The starting point and the ending point of the waves are the same. The wave pass through each other without being disturbed. Please note in this picture, the crest and the trough points are same. The crest and the crest of wave 1 and wave 2 are same. Trough of wave 2 and wave 1 and wave 2 are also same. A crest is a point on a wave. A crest is a point on the wave with maximum value of upward displacement within a cycle. Crest is maximum displacement. Trough is opposite of crest, minimum of lowest point in a cycle. Here, looking at the picture against the trough and crest are same. So if you notice, crest for both the waves are the same, troughs are also same. The maximum and minimum displacement are same. As a result of these two waves, superposition, the result is the superposition, the result is the screen is brighter, the intensity is I proportional to 4a square. Here we have noticed in picture that both crest and trough are moving together. The phase difference between the wave will be 0. Because they are moving together, the phase difference will be. As a result of these two waves superposition, the result is screen is brighter. The intensity of I is proportional to 4a square. Here we have noticed in the picture both the crests are moving together and the troughs are moving together. Therefore, the phase difference between the wave is 0. The path length difference is 0. Because the start point and the end point of the two waves is the same, so the path length difference is also 0. We will have to understand in the next slide the terminologies like phase difference, phase length. So coming up that. Understanding the terms phase, path length, a complete cycle in a wave. The wave 0 to t is a complete cycle of a wave, which includes complete path of the crest and trough. The phase is 2 by pi. It completes its half cycle in pi, that is 180. 2 pi phase for a complete cycle, that is 360 degree. Path length is lambda. This is the total length is lambda. The complete length covered in one complete cycle. So we have learned the terminologies t, time taken for complete cycle, phase 2 pi in one complete cycle, this complete one cycle of the wave, the phase is 2 pi. Path length or the path length difference, one cycle can be denoted as this complete, that is lambda. Here we are considering that the two waves is starting little late. There are two waves, one of the wave is starting little late, although they have same speed, direction, trough and crest. Then the phase difference between the two waves is 2 pi. What was the phase difference again? This is the phase difference. Okay, so if you notice, the first has already covered the 2 pi. It is starting late. And what is the difference? The phase difference between the two is 2 pi. The path length difference is lambda. This complete one cycle has been missed. So one complete length was lambda. So we will say the path difference is lambda. Okay. Just to confuse at times, we know if there are various, so it will be n lambda. So sometimes just to confuse, they give a question in the exams. They ask like this, that if numerator and denominator both are multiplied by 2, we say the path length difference is 2n lambda by 2. Then tell me, is it a constructive superposition or a destructive superposition? In this, if you notice, 2 from the denominator and 2 from the numerator and denominator gets cancelled. So we are left with n lambda anyway. So n lambda is the path length difference for a constructive superposition of two waves. So path difference, the phase difference is 2 pi, which is like 0, 2 pi, 4 pi, 2n pi, and here path length difference is n lambda. Superposition is the combination of two waves at same location, combination. Okay. It can be either constructive or destructive. Destructive interference occurs when two identical waves are superimposed exactly out of phase. They are totally out of phase. That time it will develop a destructive superposition. Here in this picture, if you see one trough, this wave's crest, okay, and this wave's trough are reaching if you put a screen here, so are reaching the screen and they cancel out each other. So what is happening in these two waves? They are identical waves, but they have different phase, because of which one wave has got crest and at the same time the other wave has got trough. So it becomes a destructive superposition and they cancel out each other. As a result, what happened? They cancel each other as one trough and one crest are reaching the screen. If you put a screen here, automatically one will reach as a crest, one will reach as a trough. The phase difference between them is pi, 3 pi. Why pi I am saying? If you remember in this screen, see, this was pi. This was pi. So they are this much distance apart from each other. Okay. So the phase difference is pi, 3 pi, 5 pi. That's the phase difference, or we can say 2n minus 1 pi. So the phase difference between the waves is 2n minus 1 pi. The path difference between them is lambda by 2. And we can say 2n minus 1 lambda by 2. That becomes 3 by 2 or 5 by 2. Mathematical analysis of superposition. Here we are taking two waves, say y1 and y2. Mathematically, we can write the formula for one wave as A sine omega t. Since the other wave we are assuming to be ahead, so we can write sine omega t plus pi. So we are considering these two formulas for two different waves. We know the formula sine A plus B. We are considering as this as A and this as B. Okay. Sine A plus B is sine A cos B plus cos A sine B. If we open this with the formula, we get sine omega t as sine A, cos pi as cos B, plus sine sine B, which will be written here, and cos A is Wt, omega t. So we get this, we have opened this formula, this part with the formula sine A plus B equals to sine A cos B plus cos A sine B. And we bring this value down because we are adding y1 plus y2 and making it a combination as y. So we are getting this value. From this, these two, A sine omega t and B sine omega t cos phi, we are taking out sine omega t outside. So we are left with A plus B cos phi multiplied by sine omega t, keeping it outside. This B cos omega t sine phi comes as it is. So it becomes B sine phi cos omega t. We are considering A plus B cos phi as R cos theta. We are considering it to be as this value. So B sine phi, we are considering it to be R sine theta. This is the values we are considering. So in place of A plus B cos phi, we are going to write R cos theta, sine omega t comes down as sine omega t, plus B sine phi, this value B sine phi is being written as R sine theta, and cos omega t comes down as cos omega t. If you notice, again we can substitute. We know sine A plus B equals to sine A cos B plus cos A sine B, the same formula that we have just utilized above. So we are going to reduce it down and write sine A plus B. So here we get it as R from here and sine this A plus B theta. So omega t plus theta. So we get this new equation as our superposition equation for as a mathematical analysis. Now here we also know I is equal to R square. What is I? I is the I equals to R square, and what is I? I is the intensity. Intensity is equal to amplitude square. So here R square, and the value for R square is, one part is A plus B cos phi. So if we put a whole square around this and open this, that becomes A plus B whole square, which can be written as A square plus B square cos phi plus 2AB cos phi. So this is one value, plus B sine square pi. So we have squared it and added them up. So this is our intensity. So I is maximum when cos phi is equal to 1. When will cos phi be equal to 1? When pi value is 0, 2 pi, 4 pi or 2n pi. When will I be minimum? I will be minimum when the value of cos phi will be equal to minus 1. When will the value of cos phi be minus 1? When the value of pi is pi, 3 pi, 5 pi, 2n plus 1 pi. Okay. So here we know intensity of a wave is I equals to, say, A square, or I equals to Ka square. K is the proportionality constant. A is the amplitude of wave. So resultant amplitude is A equals to, we can say A square plus B square plus 2AB cos pi, or we can say A1 as A as A1 and B as A2. Then we can write A1 square plus A2 square plus 2A1 A2 cos phi. We know I is directly proportional to A square. So instead of writing A, we can write I1 plus I2 plus 2I1 I2 cos pi. If all these i's are same, say I1 is equal to I2, then in that case we can write I1, 2 and we are adding these up, so it becomes 4i cos square pi by 2. So these are the formulas that you can learn mathematical analysis of superposition. Understanding what is a coherent source and how we can derive the coherent and why is it important. Coherent sources are the source that emit light of same frequency. Same frequency is required for consistent resultant light. A consistent wave is the one which gives same amount of intensity at every moment. It is possible by a simple harmonic wave represented by a single function. It is required that the resultant of two waves should be consistent so that either brightness or darkness can be noticed clearly. Condition of consistency. A consistent resultant wave can be made only by two coherent waves given by a coherent source. Coherent source, two sources of light giving wave of same frequency and wavelength and having a constant phase difference. It is not possible to have two different sources as coherent sources. Millions of electrons participate in making mean frequency of a light. The probability that one combination is same is 0. The source cannot be coherent. So how do we make coherent lights? Let's look into this picture and understand it first. There are two methods. One is slit method and one is the reflection method. So we take a single source of light. We are taking this as the first method. In this is the single source of light and let it pass through a cardboard. So this is a cardboard here and we have slit the cardboard from two ends. This is one end and this is the other end. So we are making the light pass through it. This cutout, these two sources of light wave have same frequency, wavelength and have constant phase difference because they are coming from the same source. So what all will be same in these two lights? One is coming from here and one is coming from here. Because it's coming from the same source, it will have the same frequency, the same wavelength and they will have a constant phase difference. So when they fall onto this the screen, so these all properties will be same and we will call these waves as coherent waves. Okay. Similarly, we have another method to produce coherent source, that is reflection method. Here we take a single source again. When it strikes the reflecting mirror, these two sources wave are also coherent. How? This is the source, suppose. A single source from where the light is being generated. We have placed one mirror here and another mirror here. This is the screen on which finally the two waves have to reach. So we have taken a single source. From this source, one light goes from here and reflects back onto this screen. Similarly, one light reflects on this mirror and falls onto the screen. So what will be the same in these two waves which are reaching? The frequency, wavelength and phase difference will be same. Since these are same, that is why these two will be called as coherent source, coherent waves. Interference, which is Young double slit experiment we are conducting here. I'm explaining it to here. Now in this we have this as the primary source which is being put forward by a cardboard which has been slit, the S1 and S2. So we are making a coherent wave. So S1 and S2 are two coherent sources at a distance D. So this distance between S1 and S2 is D. If the total distance from here to here is D, then half of this from here to here will be D by 2 and this will be D by 2. Correct? So we are denoting it by small d, D by 2 and D by 2. Okay. The screen distance from here all the way to the screen, the distance is capital D. O is a point equidistant from S1 and S2 such that wave from both the source reach with the same phase here. Hence, it is a bright point. Let us choose any point P at height h. It is at the height h. So, this is h. Capital or H or small h, this is h. Okay. The path then from source SP1 and SP2 will be, what will be the path difference? We are trying to take out the path difference here. So mathematically, path difference will be S2P minus S1P. This is the path difference we want. What is the value of S2P? The value for S2, which is S2P, will be in this table, in this triangle. If you see, we are going to apply Pythagoras theorem. So it will become Pn square plus S2n square. That is this Pn square and this S2n square. Similarly, for S1P square, the value will be Pm square by Pythagoras theorem. In this triangle, Pm square and the value S1m square here. Now, if we substitute the value for Pn, what is Pn here? Pn is h plus d by 2. How? This distance P, the point P and O is h. I mean, it's same right now. The small h and capital H, just consider it same. So, PO will be h and O to n is d plus d by 2. So the value becomes h plus d by 2. So we have here h plus d by 2. The value for Pm can be written as h, the total, minus this distance, that is d by 2. So we get these two values for Pn and Pm. And S2n, the distance S2n or S1m is D. So we are writing it as D. We are going further in the next slide just to implement this Young double slit experiment we were continuing. So if we put S2p square minus S1p1 S1p square. So this value, where is this coming from? What are we taking it out? Just see again. We were taking out S2p minus S1p, which is the path difference. So we are taking out the path difference and substituting the value. By Pythagoras, we have derived Pn square plus S2n square. Now substituting the value for Pn, we have h plus d by 2 whole square plus d square. Why is this d square? Because S2n value is d. Similarly, S1m value is d. Substituting all the values, solving this up, we get the value is equal to 2hd. What is this 2hd? This 2hd is equal to this, the path difference, S2p square minus S1p square, which can be written as, when we open this bracket, we can write it as S2p minus S1p bracket multiplied by S2p plus S1p bracket equals to 2hd. If we write S2p plus S1p, which the value is d, okay, so we can write it as 2d. So this into 2d equals to 2hd. Here, bringing d down in the denominator, we get hd by d. This will be the bright fringe. The distance between two consecutive bright fringe will be this. Okay, the fringe of darkness will be lambda d by d, which will be lambda. This d will go up and divided by d here. This will be the value for fringe of the dark. This will be the bright fringe. Let's look at the animation one time. Suppose this was my source. This is the cardboard to create the coherent sources, so that we have got the split here. The light will pass through this. Whenever source 1, it's going to create a wavefront here. So the wave which is when this will run over the other, when they will strike together. So this common point where they are coming together is going to form a bright fringe. Okay, let's see that. This is how it comes. The light comes out whenever they are overlapping. These points, superposition points, where this yellow line and the red line of the wavefront are overlapping each other. So this becomes a bright, dark, bright, dark, bright, dark fringes like this. So let's run it one more time. This is the screen. It will show you the bright points and the dark points. To calculate first dark point, suppose it is at point P. Then the wavelength for the dark point is hd by d equals to 2n minus 1 by 2 into lambda. Putting the value of n, say equal to 1, we get first dark point will be 1 by 2 d capital D by small d lambda. This is from where it is coming by putting the value as 1. And second dark point will be putting the value as 2 in here. We will get 3 by 2 d by lambda. So these are the values for the dark point. To calculate the first bright point here, we have taken the horizontal picture of the screen from Young double slit experiment. Let me show that again to you. Say this was our experiment here. This screen, okay, we have taken this screen down in a horizontal manner and placed it here. So once we place this screen here, then the same derivation that we have derived earlier, we are using that, and we get d lambda by d will be our bright fringe. So this is our bright fringe points. So the center point will be a bright fringe. Then this point will be a bright fringe. It will be dark here. Then similarly, you can keep putting this value in formula here, n plus 1, and get all the bright fringes points. Width when slit changed from source. This was a slit where we have cut it down. The slit is this point. This is a slit where we are making the coherent sources. In case the value of this slit is changed, then what is the impact? Okay. To make coherent source, we have made a slit on the cardboard. We are deriving a formula in case the width is reduced from 10 to 5. This was the original. It has been reduced to 5. The ratio will be slit W1 by slit W2 equals to intensity 1 by intensity 2 equals to amplitude square of 1 by amplitude square of the second. This will become our formula for the width. Okay. The ratio of intensity at maximum and minimum are, this will be the formula, that another one that you can learn and remember. I hope this was useful to you. Thank you.